We are the Westmoor Robotics Club, a high school club full of dedicated people committed to spreading STEM education in our community. We'll be going over what we do as a club and how we serve our community.
Our team participated in the First Tech Challenge FTC every year if possible. In FTC, we worked with other teams towards scoring points, coordinating our autonomous route, and negotiating a plan for the match. Our team have competed up to the regional competition and won 2 Think Awards for our engineering notebook. Competitions are a great opportunity for us to face unexpected challenges, solve problems, and work with unfamiliar people.
Computer-aided design, or CAD, is the first stage of creating a robot. The process starts with brainstorming, where members in our team come up with different ideas for robot mechanisms and sketch them out. After completing their sketches, members will recreate their designs in a CAD software, such as Autodesk Fusion 360. Here, members will create 3D models of their designs and assemble the parts together using constraints and joints. After the model is finished, it is handed over to the builders, who will use it as a blueprint for assembling in real life. Sometimes, our designs utilize parts which are custom designed, which we have to manufacture ourselves. To do this, we use 3D printing and laser cutting, as you can see here. Along with being used as a blueprint, our CAD models are also used for animations, which can help people understand how the overall mechanism works. All in all, CAD is what allows our members to turn their ideas into real working mechanisms.
What is building? It's kind of self-explanatory, but building is creating the physical body of the robot by assembling different parts and mechanisms. The main idea of building is making ideas come to life. This is because builders will have to physically build the robot while following the CAD model of the design. As builders, we are provided with many parts and tools to help create our ideas into reality. In addition, there are times when we have to customize certain parts, such as using 3D printed parts, custom length extrusions, and more. Along with that, we collaborate and work together as a team to not only build our robot, but to build a good chemistry with each other. Although the CAD model is the 3D blueprint of the design, a key element that is always essential to building is problem solving. If something goes wrong or if the calculations weren't on point, builders will have to improvise and use the power of problem solving to work around any complications or difficulties. After the robot is built, we hand it over to the programmers to make sure that the mechanisms are fully functional and safe.
After we have finished building our robot, we work on programming in order to have our robot move how we want it to move. Our main programming language is Java, but we have used Arduino and blocks in previous years. First Tech Challenges consist of an autonomous section, when the robot acts without human control, and a teleop section, when the robot is controlled by a gamepad in the distance. As you can see here, this robot is remotely being controlled by a human. For teleop, we program our robot motors to respond to different controls on a game controller. Autonomous is more complicated because the robot must move and act with accuracy during our competition without our aid. For this, our programming team divides into small groups to create certain Java programs. For example, we program motor encoders for the robot to accurately move in a straight line a given distance, gyroscopic sensors for the robot to turn to a given angle accurately, and computer vision for the robot to identify the location of an object. Once we finish programming, our robot is fully functional and ready for FTC and outreaches.
Aside from our weekly meetings and competitions, we also promote STEM through outreaches. Every outreach, we build an original bot for people to drive around. We show the respective CAD models and programming to give insight in the process of how to get to the finished bot and make it move. Using the things that we do best, we want to reach out to people of all ages that may have an interest in STEM. Westmoor Robotics not only strives to impact the people in Westmoor, but to also inspire future engineers and aid in the spread of STEM all around the community.
Westmoor Robotics is
passionate, enthusiastic,
Interesting.
cool,
Innovative,
Collaborative.
Inspiring,
epic,
creativity,
engaging,
motivated,
fun.